I have the unenviable task of describing for you Bayesian active inference or predictive coding models of interoception, and doing so in 5 minutes. So let's go. All right, so the first thing you need to know is that for decades, neuroscientists understood the brain primarily as a stimulus response organ, wherein neurons lie dormant until they're stimulated. Sort of in this traditional model, cognition's role was simply to sort of modulate neural activity that's being driven primarily by sensory events in the world. Now, the way this played out in the study of interoception was that, let's get our, so this is our insula, was that you have afferent signals that came in from the body primarily to posterior insula, and then there was a process along the longitudinal axis of the insula to re-represent in terms of higher and higher order representations interoceptive information, and then from this most anterior part of the insula, then this information was then made available to the rest of the brain to influence behavior and that sort of thing. Well, in other areas of neuroscience, other particular areas of sensation and motor function, there's been this developing idea of active inference. So in a very, very sort of high-level description of this, the idea is that the brain's role, particularly higher cognitive centers, are constantly working to predict the causes of incoming sensory information. Those predictions are relayed down a cortical hierarchy to sensory areas that are actually receiving sensory signals from the periphery, from the outside world. And then the role of those sensory regions is to compute the difference between the prediction and then what's actually being received, and relay that information, that difference, back up the hierarchy as prediction error. And that's what's actually sent back up the hierarchy. And then these regions then adjust their predictions based on the prediction error signal that they're getting. Now, how would this play out in terms of interoception? So one account of this that was put forth by Lisa Feldman-Barrett and myself last year, the EPIC model, basically says that visceral experience, visceral signals come into particularly the mid and posterior insula, and that the computations of the mid and posterior insula compare the bottom-up signals from the body with the top-down signals from other brain regions, particularly anterior insula and viscera motor regions, regions that, in terms of their cytoarchitectonics, are primarily agranular limbic regions. And so it compares those prediction signals about the body's expected state that are based on prior experience and information, right, that are coming from these other systems that support cognition and emotion, with the incoming signals. It then sends the difference back up the hierarchy as prediction error. And those prediction error signals then adjust are taken into the computations of the subsequent predictions and adjust the output until eventually you settle in on a perceptual experience. So the function, according to this model, the function of the viscerosensory insular cortex is to compare information about the expected and actual state of the body, and then relay back out to the wider brain the difference between the two. Now, there's some other active inference models of interoception I think really should be noted, particularly models from Anil Seth and Hugo Critchley, and also from Xiaoji Gu and Carl Friston. These are excellent models and have really important features to them. The thing I want you to get is that what all of these models have in common is that they use the principles of active inference to explain how afferent visceral signals are integrated with higher cognition, emotion, and autonomic control. So they start to kind of provide a way to think about how a lot of the peripheral systems that we've been hearing about this morning integrate with higher cognition and emotion. These models highlight the idea that interoception is not simply passive processing of body signals that only become available to the wider brain after they've been highly processed in the insula. But instead, interoception becomes the integration both of what is happening in the body and the brain's pre-existing models of what is happening in the body. So, why is this important? Well, the reason why I think this is important is that this perspective suggests a new way of thinking about psychiatric illness, particularly illnesses that have a strong interoceptive or somatic features, such as anorexia nervosa or depression. These are not just disorders of aberrant afferent body-brain signaling, but possibly also aberrant brain-body predictions. And if that's the case, this suggests that we should start paying attention to and developing interventions that address patients' interoceptive predictions. And that's something that we're going to talk about in the next workshop.